after your summer vacation? What, Priyaranjan? So you had almost a month of vacation. I hope that you have not forgotten the syllabus that we have covered before the summer vacation. That is why in between we kept some practice classes also. I don't know how many of you attended it, but if you attended that, then you may have some revision of the chapter also. Anyhow, today my intention is to revise light chapter once again. I will not revise only the reflection part, I will revise the complete chapter, and I can see some new faces also, like you, what is your name? Sudhish, attending the first physics class, right? My physics class, isn't it? And I think you came for my class earlier. Your name is? Santosh. Anybody else who's sitting for their first class? I think he's sitting for his first class. He's in your school only. Is he in your school? What is your name? Renit. Yes. And there I can see Mridini, Nitin, Helen, Tejashwini. Tejashwini joined online. Why? What happened? Not came here. Srinidhi also online. Helen also online. Why are you people attending online class? Tejashwini? Why did you not come for the offline class today? Yes, I am asking you, Tejashwini. Why did you not come for the offline class today?
I was not feeling well.
Srinidhi, what about you? You also not felt well today?
Sir, I didn't hear you. I'll come back.
Okay. Helen, what about you? Why are you attending online? Huh? Okay. Nitin, I think you are going to come online only, right?
Yes, sir.
Okay. You are comfortable in online classes?
Yes, sir. It reduces the travel time for you.
You are coming from Vadapalni?
Sir, no, sir. Nearby, but it
Huh.
takes 10 minutes to go and 10 minutes to come. 20 minutes for me.
Okay. Okay, good, good. If you are utilizing it well, then fine. But I am seeing sometimes in between you are eating French fries and all.
Sir, chips is sometimes I'm not do.
Yeah, chips only. So avoid that. Have your focus in class. Okay. And
Okay, sir.
your school reopened or still is not reopened?
Tomorrow only it reopens, sir.
Okay. When you are going to have exams in your school?
Around June 21st, sir.
What is the portion?
The third week.
Portion?
Still, now only they have finished electricity.
So
First, sir.
electricity, are you fine in electricity?
Yes, sir, but I am confused in voltage and heating effects, sir. That's
If you have some doubts, you can come someday and learn from me the chapter. Okay.
oh, yes, sir.
Yeah, fine. So let us go into the class today. And as I said, I have finished light chapter here. Literally, last class when I taught, I think I even taught what is power. Am I right? So I have finished the chapter. Power I have taught or not? No. Did I teach power or not? Power is 1 by F. I have not taught all these things. Notes is there. You can check the pages whether I taught or not. You said I not taught. That's why it confused me now. You're writing math, physics, everything in same notebook, no? Let the mentor meeting happen. Yes. What is the last topic I taught? Those who wrote, huh? Power of lens. I gave definition. You wrote the formula. Okay, I have taught power also, man. Combination of power I taught. 1 by F1 plus 1 by F2. Those things I not taught. Okay. Today we will learn all those things also once again. Fine. So coming back to the class. So this light chapter, if you see as a whole, this chapter has mainly two parts. One part is talking about reflection. One part is talking about refraction. So light chapter, there are two major parts in this chapter. One is talking about reflection of light. One is talking about refraction of light. Let us start with the reflection of light. So you know very well what is the meaning of reflection. Reflection is bouncing back of light when it hits a surface. And there are two laws of reflection. Whenever the light is hitting a surface, it follows these two laws. First law is incident ray, reflected ray and normal. It lies on the same plane. And second is angle of incidence is always equal to angle of reflection. So if you have a surface and if you have light hitting the surface, then the first step I have taught to you is to draw the normal. I have told this to you in the first class of light, that when you draw the incident ray, have a habit of drawing the normal first, and the moment you draw the normal, the angle made with the incident ray is called as angle of incidence. The same angle will be made by the reflected ray, and that angle will be called as angle of reflection. As per the laws of reflection, these two angles will always be equal. That is what is the law of reflection. So, then we have mirrors in this chapter. So, reflection, there are how many types of mirrors? If I broadly classify, then there are two kinds of mirrors. One is plane mirror, second one is spherical mirror. Spherical mirror can be further classified in two kinds. One is concave mirror, other is convex mirror. What is a plane mirror? Where you see yourself daily, right? The plane mirror is something where you have a glass and you paint one side of the glass with ammonical silver nitrate solution, and it becomes reflecting on one side and it remains polished on the other side. This kind of setup is called as a mirror. And in mirror, if you stand, plane mirror I am talking, if there is a plane mirror, if you stand in front of a plane mirror, then you see your image inside the mirror itself. That kind of image which is seen inside the mirror is called as virtual image. So, the image formed by the plane mirror is virtual in nature. Since it is virtual, it is also erect, isn't it? And if you stand in front of a plane mirror, your image will have the same size as you. It is not like image will become big or it will become small. So, the size of image will be same. So, image will have same size. I am writing the nature of image formed by a plane mirror. So, image will be virtual, image will be erect, image will be of same size, and image will be at same distance as that of object from the mirror. If you are standing 10 centimeter in front of a mirror, your image will also form 10 centimeter inside the mirror. If you go behind, the image goes behind. If you come close, the image come close. So, the distance of image and distance of object is always same in the case of a plane mirror. We also know that by a plane mirror, lateral inversion takes place. Am I right? What is the meaning of lateral inversion? Our right becomes left and our left becomes right. This kind of inversion is called as lateral inversion. See, in this chapter we have two kinds of inversion. One thing is vertical inversion, by which we say the image became inverted. That is top becoming bottom. And here I am talking about lateral inversion. Lateral inversion means right becoming left. So, if you stand in front of a mirror and if you raise your right hand, it feels like you are raising your left hand. That is how what behaves? A mirror behaves. So, whatever I have told you now are the characteristics of a plane mirror, image formed by a plane mirror. Then we have learnt about spherical mirror. So, spherical mirror is take a sphere of glass, something like I told you, imagine a football made up of glass, and you cut a part of it. That part, if you polish, there are two possibilities of polishing. Either you can polish from the outside of the curved part, or you can polish from inside of the curved part. So, in this curved part, if I am polishing on the outside, I am going to get a concave mirror, or on this curved part, I am going to polish inside, I am going to get a convex mirror. So, a mirror becomes concave or convex purely depending upon which side you are polishing, whether you are giving a polish in the inner part or you are giving the polish in the outer part. If you give the polish in the outer part, it is a concave mirror. If you give the polish in the inner part, it is a convex mirror. So, concave mirror, it has a nature that whatever light is falling on it, it will converge the light. That is why this mirror, apart from being called as concave mirror, is also called as converging mirror. Why converging mirror? Because it has a property of converging the light falling on it. Light comes, if a mirror is converging it, then the mirror is a concave mirror. On the other hand, if you have a mirror and the mirror is diverging the light, but in such a way that you extend in the back side, it meets. This mirror is called as diverging mirror because it has a property of diverging the light falling on it. So, spherical mirror is of two types, concave and convex. Concave mirror is called as converging mirror because it converges the light falling on it. Convex mirror is called as diverging mirror because it diverges the light falling on it, right. Now, concave mirror, whenever the light is falling and it is being converged, the point at which all the light gets converged is called as focus, right. This focus is a real focus. Why do I say it is a real focus? Because rays are really meeting to form the focus, isn't it? I will draw it here, Joshita. So, if you have a concave mirror and light is coming from far, it is going to get converged. If it is going to get converged at a point, I am calling this point as focus. You can see very clearly that the rays are really meeting to form this focus. That is why it is called as real focus. And if you consider a what mirror? A convex mirror, where the light comes, gets diverged, light comes, gets diverged. It seems to pass at this point. This point, the ray is not really meeting, it seems to meet. I hope you are getting my point. Rays are not really meeting to form the focus. This kind of focus is called as a virtual focus. So, remember, the focus of a convex mirror is a virtual focus, but focus of a concave mirror is a real focus. I am once again repeating, real focus is found by the concave mirror, or real focus is the point where the light is getting converged. So, rays are really meeting to form the focus. That is why it is called as real focus. Here, the light seems to meet. This focus is called as virtual focus. All these things we have learnt in the previous classes. So, then I have taught to you about the properties of the mirrors. That is, if you have a concave mirror or a convex mirror, you know very well that mirror has been derived from a sphere of glass, isn't it? You have a sphere of glass. From this glass only we are cutting out some portion and we are forming a mirror. If I cut out like this, then I am getting a, and if I polish like this, I am getting a concave mirror, isn't it? So, any spherical mirror, whether it is concave mirror or it is a convex mirror, it comes out from a part of sphere. The center of the sphere from which the mirror has been taken out is called as what? Is called as center of curvature. So, what is center of curvature? Center of curvature is the center of the sphere from which your mirror has been cut out. Simple. If I draw a line which is passing through center of curvature and cutting the mirror, this line I am calling as principal axis. The point at which principal axis is intersecting with my mirror, this point is called as pole. So, what is a pole? Pole is a point where the principal axis is intersecting with my mirror. Then you know very well that all the light ray falling on this mirror, at which point it gets converged, that point is called as focus. Then I said you, distance of center of curvature from the pole is called as radius of curvature. Distance of focus from the pole is called as focal length. All these terms you must know because anything can be asked in the examination. They may ask you what is center of curvature, what is focus, what is pole, what is radius of curvature, or what is focal length. You must write a definition correctly. I am repeating once again everything for you. Center of the sphere from which the mirror has been derived is known as center of curvature. The point at which the light ray seems to converge after getting reflected is called as focus. Distance of center of curvature from the pole is called as radius of curvature, and distance of focus from the pole is called as focal length. These definitions should be there in your head because anything can come in the examination for you. Definition. Okay. Then I said to you that mathematically radius of curvature is always twice the focal length. Remember this. So, whenever you are drawing an image formation, if you are drawing this as 2 centimeter, this must be once again 2 centimeters. Or if it is 2, this must be 4. However you want, you can say. What happened here? Suddenly how eraser came. So if you have this as 2 centimeter, then this must be 4 centimeter. So whenever we are drawing this diagram also, we take in such a way that don't randomly draw in the ray diagram. I am seeing students randomly drawing in the notebook. Somewhere they will draw focus, somewhere they will draw center of curvature. They will not get the image formation correctly. So have a habit whenever you are drawing an image formation, because it comes in the school examination. Draw the image formation. For various cases they may ask you. But whenever they ask you the image formation, have a habit that you will keep the distance of focus from the pole and distance of focus from the center of curvature same. That is, if you are drawing it as 4 centimeter, it is also 4 centimeter. Then only your ray diagrams will happen correctly. So before I start talking about the ray diagram, you must remember what is the rules of image formation. Again, it is very important. Without understanding the rules, you cannot draw the image formation properly by yourself. You have to mug up. If you understand how the rule works, then the image formation is very simple for you. Let me tell you how the rule works. So if you see, the first rule says that any ray which is passing parallel to principal axis will converge and pass through focus, isn't it? If it is a convex lens, then it will, if it is passing parallel to principal axis, it will diverge and seem to pass through focus. This is the first rule. So first rule of image formation says that any ray which is passing parallel to principal axis will converge and pass through focus, or any ray which is seeming to which is parallel to principal axis will seem to pass through focus if it is a convex mirror. Second rule is the vice versa of it. Second rule says that if any ray is passing through focus, it will become parallel to principal axis like this, right? For a convex mirror, if I draw, then if there is a focus like this, and if a ray is trying to pass through this focus, then it will pass parallel to principal axis. Are you getting? So if any ray is passing through focus, after reflection will become parallel to principal axis, or if any ray is seeming to pass through focus, in the case of convex mirror, that will also become parallel to principal axis after reflection. This is second rule. Rule number 3. Rule number 3 tells that if any ray is passing through center of curvature, what happens? It will retrace its path. Why does it happen? Why the ray is retracing its path? I have told to you. Any ray or any line that is drawn from center to the mirror is actually a normal line. I told this to you. See, I said that if even this image formation is happening, how it is happening? The moment first you draw the incident ray, you must draw normal, right? For drawing the reflected ray. This normal, when you are going to draw, it will pass through what? Center of curvature only. So this is the incident ray, this is the normal, and then you have a reflected ray, isn't it? So what we come to know that any ray which is passing through center of curvature, or any line which is passing through center of curvature, is a normal line. So if a ray is passing through center of curvature, it is passing through normal line, doesn't mean that it is normal incidence. So ray has come on the normal itself, what will happen? It will go back in the same direction. Why? Because angle I is 0, angle R will also be 0. Angle I is equal to angle R as per the law of reflection. That is why if a ray is passing through center of curvature, it retraces its path. Or in the case of convex mirror, if I would have a convex mirror like this, then this is center of curvature. If ray is seeming to pass through center of curvature, then also it will retrace its path. Rule number 3. Rule number 4 says that if any ray is passing through the pole, it will make the same angle as made by the incident ray with the principal axis. Why? Because this line is also a normal, isn't it? It is passing through center of curvature, no? Any line passing through center of curvature and going and cutting the mirror is a normal line. So this becomes normal. Whatever is this angle I, the same will be angle R. So this is the rule number 4. I will repeat once again all the rules. Any ray passing parallel to principal axis or seeming to pass through parallel to principal axis will converge and pass through focus or diverge and seem to pass through focus. Any ray passing through focus or seeming to pass through focus will become parallel to principal axis. Any ray which passes through center of curvature will retrace its path, because any line which is joining the center of curvature with the mirror is a normal line. And the fourth rule is, any ray which is making some angle with the pole will make the same angle with the pole after reflection. Clear? With the help of these 4 rules only, we start learning about the image formation by mirrors for various object positions. Okay, I am not going to draw all the image formations now. I am going to draw a bigger diagram. So I hope you know how the image formation takes place. I'll just draw a random thing and tell you. For example, object is kept between F and C, focus and center of curvature. Then I'm just teaching you how to draw the image formation in the school. If the question comes, always have a habit of drawing a very less aperture. Don't draw a very curved mirror like this. Always have a habit of drawing mirror with the least curvature. Very smoothly you should draw. And then mark the focus. Suppose I am giving 4 centimeter. Same 4 centimeter I will mark the center of curvature. Then when you draw the object is kept between what? Object is between F and C. So I am drawing the object here. If the object is drawn between F and C, let this be A, B. The ray is going to go, hit and pass through focus. Second ray is going to go and pass parallel to principal axis. They both are going to meet here. I am going to draw the image A dash, B dash, isn't it? That is how you should draw the ray diagram in the school also. Don't forget, these arrows are very important. If you miss to give the arrows, they will cut marks. Labeling of object and labeling of image is very important. If you fail to do that, they will cut the marks. This stroking, showing that it is a concave mirror, is also very important. Some students just drawing like this, they won't give marks for that, because it can be a concave mirror also, it can be a convex mirror also. Am I right? Based upon the polish only we decided it's concave or convex mirror. So always have a habit of giving the strokes, proper strokes. So this is the image formation by a particular mirror for a particular condition. Now, always have a habit, whether they ask in the examination or they don't ask in the examination, to write the nature of the image. So you can see from here, nature of the image is, it is real, isn't it? Why the image is real? Because rays are really meeting to form the image. So what is the nature of image? Real and inverted. What else? Whether it is enlarged or diminished? Enlarged. Location? Isn't it? So 3 things you must write. One is its location, one is its size, and third one is its nature. So location is beyond C, size is enlarged, and the nature is real and inverted. It is must. You must write the nature of the image, whether they ask or they don't ask. Okay? And the most important image formation in the case of concave mirror is the last one, where the object is kept where? Object is between F and P. You remember this? Because here is where you will make mistake in image formation. I'll draw the pole, I'll draw the focus, I'll draw the center of curvature. Then I am going to draw the object between F and P. The first ray will go, pass parallel to principal axis, will converge and pass through focus. The second ray will pass through center of curvature and it will retrace its path. Now when we are going to extend in the back an image, join this, I am going to get a virtual, erect and enlarged image. So for this object AB, I am going to have a virtual, erect and enlarged image formed. So what will be its nature? Virtual, erect, size, enlarged, location, behind the mirror. or inside the mirror, however you are comfortable. So, inside the mirror or behind the mirror, and it is going to form enlarged image. Is it clear? So, these two I have drawn because these two are important for the school examination. I am going to draw all the other image formations also now in a single diagram. Shall I do that? Which will help you to understand where will the image form, what will be its nature, what will be its location for concave mirror. So, now I am going to do, I am going to draw a concave mirror, and in the same concave mirror I am going to take various object positions and you are going to get the image formation. So, I am going to use one color for object and I am going to use some other color for image. So, first I am going to do one thing, I am going to keep the object at various positions. So, now we are going to find the image formation by a concave mirror for various cases of object positions. So, object is at infinite, object is beyond C, object is at C, object is between C and F, object is at F, and object is between F and P. For all these things, for all these object positions, image where it will form? If the object is at infinite, image will form at focus, it is real, inverted and point sized. When the object is beyond C, image will form between C and F, real, inverted, inverted. When the object is at C, image will form at C, real, inverted, same size. Object is between C and F, image is beyond C, real, inverted, enlarged. When the object is at F, image will form at infinite, real, inverted, highly enlarged. When the object is between F and P, image will form inside the mirror, virtual, erect, enlarged. So, you must, if you remember this diagram, then you remember all the scenarios of mirror, isn't it? So, what you are noticing in the case of concave mirror, as the object is moving towards the focus. So, object is moving from where to where? Object moves from infinite to focus. The image moves from where to where? Focus to infinite. Am I right? So, remember this. Whenever the object is coming from infinite towards the focus, image starts going from focus towards the infinite, becoming bigger, bigger and bigger. You could see that small, big, same size, bigger, much, much bigger. That is the property of concave mirror. So, suppose in front of you there is a concave mirror kept and they have not told you it is a concave mirror. How do you identify that it is a concave mirror? Answer is very simple. You stand in front of it. If you stand in front of it and you do not see yourself and you come little close to mirror and suddenly you see yourself inside it and then you are enlarged, it must be a concave mirror. Am I right? Because concave mirror has a property of forming a virtual image if the object is between F and P and not forming any virtual image until the object is at F. Am I right? So, if you are standing beyond F, you will not see yourself inside the mirror. But the moment you come between F and P, you will start seeing yourself inside the mirror, but you will be in the enlarged form. So, you can understand that it is a concave mirror. Sometimes the question has come in the board examination, the same thing that I am asking you. How without touching a mirror, you will identify whether it is a concave, convex or a plane mirror. So, if you stand in front of a mirror and you see an enlarged version of yourself, it must be a concave mirror, because concave mirror is the only mirror which can form virtual and enlarged image. No other mirror can form this. So, virtual enlarged possible only by which mirror? A concave mirror, isn't it? Same way, if I draw this setup, this diagram for a convex mirror, what I am going to get? Let us try to see. So, if I am going to have a convex mirror like this, and once again I am going to keep the object, but now since it is a convex mirror, there is no question of keeping the object that side, it is a polished side. So, you must keep the object somewhere here only. So, we can keep the object at infinite and then we can keep some random locations to see where is the image forming. Okay. If you see that in the case of convex mirror, the image when the object was kept at infinite will form at focus, it will be virtual, erect and point sized. In the case of object anywhere 2, 3 or 4, you are always going to get a virtual, erect, diminished image forming between P and F inside the mirror. So, if a mirror is in front of you and you stand in front of it and you always see a small version of you, it must be a convex mirror, because convex mirror always forms a diminished image. I hope it is clear to you. So, if you are standing in front of a mirror and you are seeing a small version of yourself, you are standing in front of a convex mirror. If you are seeing a bigger version of yourself, you are standing in front of a concave mirror, and if you are standing and seeing yourself in the same way how you are looking, then you are standing in front of a plane mirror. Is it clear to you? These things we have learned in detail in the previous classes. I am not giving notes to you, but those who are new must take the notes from the video. I will share the video link with you. But all these things I have given notes in the class itself. Okay? Today I am not giving those, today I am revising everything. In my class I am just giving revision to all the topics. Now the questions can come from the applications of mirror. They may ask you what are the applications of concave mirror, application of convex mirror. They may ask this question to you. So concave mirror, many applications are possible. That mirror can be used by the dentist to see the cavities in your teeth. Obviously concave mirror. Which object position will be there? Between F and P, because if the object is between F and P, image will form inside the mirror, virtual, erect, enlarged. So, if you are seeing yourself in an enlarged version, then you are using the concave mirror, that is for sure. Okay. Then what about the headlights of the vehicles? Convex headlights I am asking, not the rear view mirror. Concave mirror obviously, because concave mirror what it will do, the bulb will be placed on the focus of the mirror for the headlamp. Since the bulb is kept at the focus, whatever light comes out of the bulb, it will get reflected and become parallel beam of light, isn't it? Because any ray passing through focus will become parallel to principal axis. So, to get a strong beam of light, we are keeping a reflector, we say it, a concave reflector in the headlamps. Okay, rear view mirror, convex. Why? Because in rear view mirror, you want to get a wider field view. Very important term in the school exam. You must write this, wider field view. So, in your small mirror, you must be able to see how many vehicles are coming behind you. That is the use of rear view mirror, right? Driving a bike, mirror is there, you should be able to see who is coming behind you. If you are seeing one person, then it is not of any use. I must be able to see how many vehicles are coming behind me. So, only if I use a convex mirror, I will get a better field view. Reason is, in the case of convex mirror, wherever the object is, image is formed inside the mirror, isn't it? Wherever the object is, image is formed inside the mirror. But if you see a concave mirror, up to this point, image is not formed itself. Are you getting my point? So, we cannot use concave mirror. Behind people will not be visible to you in the screen itself. We must use a convex mirror for rear view. Okay. What about this thing? Solar cooker. Which mirror? Concave mirror. Because we will keep the cooker at the focus. Sun rays are coming from infinite. It will get converged at the focus and our food will get cooked. Isn't it? Antennas, dish antenna. Dish antenna is what mirror? It is not a mirror actually, it is a concave surface, because it also wants to attract all the signals from the space, the radio transmission, and it will focus on the knob of the antenna, isn't it? If I ask you the shaving mirrors, object should be between F and P. Once again, nowadays nobody is using concave mirror for shaving, we are using plane mirror only. But if you go to some this thing, parlors and all, they may use concave mirror also to very closely see how your shaving and all these things are taking place. Makeup man, concave mirror, isn't it? If I ask you in the hairpin bends, in the valleys, in the parkings? Concave or convex? Convex. Why? Once again, to get a better field view, larger field view. Wherever you need larger field view, you go for a convex mirror. Are you getting my point? I hope it is clear to you. So, any of the applications can be asked to you in the examination. Sometimes they may ask you to write in explanation how dentist is using concave mirror for seeing the cavities. You must be able to explain that by using a concave mirror, the cavity is kept between F and P of the concave mirror. Then the image of the cavity is formed inside the mirror as enlarged. So, doctor can easily see the cavity. Sometimes the question is asked like this, they want you to explain how the mirror is used for a particular application. Should be clear in that. Okay. After this, we have learnt about the image formula, mirror's formula I should say that. What is mirror's formula? 1 by F is equal to 1 by V plus 1 by U. Okay. Mirror's formula relates U, V and F, isn't it? So, the formula is 1 by F is equal to 1 by V plus 1 by U. What is U, what is V, what is F? U is the object distance, V is the image distance, F is the focal length. So, they are related by this formula. And we have magnification. What is magnification? Minus V by U. What is the meaning of magnification? Magnification is ratio of height of image to height of object. So, if they ask you define magnification, what will you define? Magnification is the ratio of height of image to height of the object, right? And for mirrors it is minus V by U, for lens it is V by U only. For mirrors it is minus V by U. If you ask me how these things have come, you will learn derivation in 12th standard. For both, derivation is there in 12th standard. Okay. So, now before we start seeing some questions based upon this, how to solve the questions from here, you must remember or you must understand how the convention works. So, I have told this to you, once again I am repeating because I am seeing students are doing mistake only here. They will take a numerical and they will do some mistake in sign convention and they will miss marks. If you do not want to miss marks, be very clear in the sign convention of the mirrors and lenses also. What convention says? Convention says, the first rule of convention is all the distances must be measured from the pole. Whether it is a concave mirror or a convex mirror, you must measure all the distances from where? From pole. Never forget that. Now, you have focus here, you have center of curvature here. In this case, you will have focus here and you have center of curvature here. Now, the distance of object from the pole is called as object distance, right? Distance of center of curvature from the pole is called as radius of curvature, and distance of focus from the pole is called as focal length, isn't it? If the object is kept between C, beyond C, where will the image form? Between C and F. It will be real, inverted and diminished. So, what will be the image distance? Distance of image from the pole. Now, we have four things here: U, V, F, R. The rule says that all the distances measured against the direction of incident ray is taken as negative. Clear to you? So, if you are having this as the direction of incident ray, then focal length, image distance, object distance and radius of curvature, everything is measured against direction of incident ray. So, what will be taken? Everything will be taken as, I hope you understand this. So, all the distances which are measured against the direction of incident ray is taken as negative. But see, say in concave mirror, if I would have kept the object here between F and P, where will the image form? Behind the mirror, virtual, erect, enlarged, isn't it? Now, U is negative, what is V? Positive. Are you getting my point? This is the first convention. First convention says that all the distances measured against the direction of incident ray is taken as negative. All the distances measured towards the direction of incident ray is taken as positive. Second law says that all the heights measured above the principal axis is taken as positive, and all the heights measured below the principal axis, this is taken as negative. So, here HO will be positive, HI will be negative. Here HO will be positive, what will be HI? Positive. I hope you are understanding this. So, in the case of a concave mirror, U, V and F, U will always be negative, don't you think so? Wherever you keep the object, it will be always having negative convention only. What about V? V will always be negative only in one case, it can be positive. Which case? If the object is between F and P. What about F? Positive. Always negative, man. How can it be positive? F this side, no? F is always negative. So, concave mirror is always having a negative focal length. Remember this. Remember this, very important. F is always negative for a concave mirror. U is always negative for a concave mirror. V is negative, it may be positive. Which case? If the object is between F and P. In the case of convex mirror, let us see, wherever you keep the object, where is the image formation? Between, inside the mirror, between P and F only. So, you can see very clearly U will be negative, but V will always be positive. So, for a convex mirror, U is always negative, but V is always positive. What about F? Always positive. How? Because it is this side. This should be in your head. If you are trying to mug up, you will make a mistake. Understand how it has become negative or positive. Is it clear to you? I hope you remember this. I also taught you in the previous classes how to understand magnification. For example, if I am asking magnification is minus 0.5, Priya Ranjan, if magnification is minus 0.5, think for 2 minutes and say whether the image is diminished, enlarged, whether it is real, virtual, whether it is concave or convex mirror, where is the object, where is the image, everything. M is minus 0.5, give me all the data about the image or the mirror used, object location, image nature. Fast. M is negative 0.5.
Sir, it is diminished, real and inverted, but how can we find the position of the object?
I'll tell you. So, diminished, real, inverted. Which mirror it can be, Nitin?
Concave, sir.
Concave. Why you say concave, Nitin?
Sir, convex mirror always produces
Virtual image.
direct.
Yes, correct. So, it is a concave mirror for sure. Concave mirror it is there. In concave mirror, which object position will give you diminished image, Nitin?
Sir, at infinity,
At infinity it is point sized, not diminished, right? So, where?
then beyond C, sir.
Beyond C. So, automatically you came to know the object position, it is beyond C. Image position between C and F. Image nature, real, inverted, size, diminished, isn't it? So, as I told you in the previous class, whenever magnification is given as any number, always remember that treat it as plus or minus A. What are the possibilities? This plus or minus, take it as separately. For example, if it is minus 0.5, don't think it is less than 1. Are you getting my point? You should treat it only plus or minus separately and its magnitude separately. If it is plus, it means it is virtual and erect image. If it is minus, it is real and inverted image. A has 3 possibilities. A can be equal to 1, A can be more than 1, A can be less than 1. If A is equal to 1, image has same size as that of object. If A is more than 1, then image is having magnified, image is magnified, and if A is less than 1, image is diminished. So from here you can say if M is minus 0.5, negative indicates it is real and inverted, and 0.5 indicates less than 1, diminished. So real, inverted, diminished. Which mirror can form? Only concave mirror can form. What you are asking, Priyanjan? Ask me now. Clarified, no? Yes. So whenever any magnification is given, treat its sign separately and magnitude separately. Many will confuse in this also. If I say M is equal to minus 1.5, many will think minus 1.5 is less than 1, so it must be diminished. No, you should not see minus now. Minus separately, 1.5 separately. Okay. So if M is equal to minus 1.5, now tell me, I forgot names of everybody. Ryan Ahmed, tell me, M is equal to minus 1.5. What is the image nature? Which mirror is used? Everything. Tell fast. Which mirror is used? Concave. Good. What is the image nature? Real inverted. Very good. Size? Why diminished, man? 1.5 is less than 1. Enlarged. Enlarged, real, inverted, concave mirror. Where should the object be placed to get a real, inverted, enlarged image? At F it will become good. So object between C and F, image, beyond C, real, inverted, enlarged. Clear? Okay. Next question is for what is your name, man? From P it starts. Prajin, yes. Prajin, M is minus 1. Fast. Yes. Yes, good. Magnified. So 1 is more than 1, right? Yes. Then 1 is equal to 1. No? What is? Huh? A equal to 1 means what? What size? Same thing you are saying. Minus 1 is more than or less than 1? Less than 1. So, but I should not say minus and 1 together, man. Negative separately, 1 separately. Negative indicates it is real inverted. 1 indicates it is same size. Which mirror can form real inverted same size? What is the object location? At C. Object at C, image will also be forming at C, isn't it? Okay. Ritesh, Rinit, M is equal to plus 0.3. Think and say. M is plus 0.3. Fast. I am not asking, first step by step, plus whether it is virtual erect or real inverted. Virtual erect. And 0.3 is same size, magnified or diminished? Diminished. So you are saying virtual erect diminished. Which mirror can form this? Convex. Then why you said concave in beginning? Concave mirror will never have plus magnification. Remember this. It will have, but it should be more than 1. Right? What is your name? Sai Darshan. M is plus 5. Fast. Which mirror? Which object position? Between? Siddharth, if you are able to hear me, can you please unmute yourself? You are from 12th standard, right? You are from 12th, no? You can drop the meeting now, join at 7:10 or 7:15, okay?
Okay, sir.
Yeah. Yes. Tell me, Sai Darshan. Good, very good. 5 is less than 1, equal to 1 or more than 1? 5 is less than 1, right? Then what I have written there, man? More than 1 means what? magnified, enlarged. You should be there in class, you are sleeping, talking to him, then how will you listen to what I am saying? Enlarged. Virtual, erect, enlarged. Concave mirror can only form. Concave mirror, object between F and P, image inside the mirror. Understood? Forgot everything what I have taught before this. Diksha. Diksha, right? Daksha. Okay, sorry, here I am forgetting names. M is equal to plus 1. Daksha. No mirror can form. Sure. No. One mirror can form. Plane mirror you forgot. Plane mirror is forming virtual, erect, same size, isn't it? Plane mirror is the answer. Are you getting? So you may get a question from here also. You may get a question from here also where they will give you the magnification, and from magnification you have to judge the object location, image location, mirror type, image nature, image characteristics. Very simple it is. Again I am repeating, see the plus or minus and the magnitude separately. Don't treat that minus 1.5 is less than 1. Minus means real inverted. 1.5 is more than 1. So, it will be real, inverted, enlarged. Okay. So, time is up for today's class. I think your school portions also for the upcoming week school examination is up to here only, isn't it? So, go and practice numericals from here, and this Sunday's test you have physics, right? Science you have. I am not going to keep anything from human eye. The portions will be only light. Okay? Fully light. This Sunday's test you will have light chapter test, full chapter. Don't think partial chapter. Full light chapter. Even lens will be there. Even those who are new students, attend the test. Don't think that how I will write, what I will write. Write whatever you know, you write. Okay? Can convex mirror form an enlarged image? Is it possible? This is convex mirror. Any enlarged image is there? Then? Which test papers here? I don't know. You know, Sir only took the test, no? I was not there that time. The sir took the test, he will give the paper to you. Okay. 1 second, I will take the attendance. Don't go now.